Okay, so this is our first video in our topic on quadratic algebra, and we really just want to spend a little moment reviewing our expansion of brackets. And we looked at this in detail in topic 1 back at the start of term 1. So I just want to quickly go through some of those things and just give you the opportunity to get some practice in before we continue on with the topic next week. So we'll recall sort of our rules for expanding brackets. So we have the distributive law, which is when we just have one term outside of a bracket, a bracket x plus b, and we expand that out by doing a times x plus a times b to get ax plus ab. The double distributive law is when we have two sets of brackets, each with two terms, or we could have more than two terms, but we'll have a look at this as an example. So really, essentially, we just need to think about the fact that each term in the first bracket needs to multiply each term in the second bracket. So a times c, a times d, plus a times d, plus b times c, plus b times d. And sometimes you might have used the acronym FOIL to help you avoid missing a term. That is first, outside, inside, and last. So you multiply the first terms in each of the brackets together, a times c, the outside terms in the brackets together, a times d, the inside terms in the brackets together, b times c, and then the last terms in the brackets together, so b times d. What I want you to be able to focus on though, and we've talked a bit about this, and I'm going to refer to this specifically in relation to these last three rules here, is I want you to be able to focus on expanding efficiently. I don't want you to write out 4 separate multiplications if you don't need to. So if your brackets are x plus a times x plus b, okay, which is what we'll commonly see throughout the quadratics chapter. So if we have x plus a times x plus b, when we do x plus a times x plus b, we get, using FOIL, x times x, x squared, outside x times b, so plus bx, inside a times x, so plus ax, and last a times b. Okay, and we get these common like terms, bx plus ax. Okay, and so if we take out that common factor of x, we get b plus a or a plus b. Okay, so quicker, if you have x plus 2 times x plus 3, you're not going to write out 4 terms. You're simply going to straight away go to, it's x squared plus 2 plus 3, 5x, plus 2 times 3, 6. And you need to get better at being able to do that in your head. Even if in your head you're saying x squared plus 3x plus 2x, that's 5x. And don't bother writing down the step where it's plus 3x plus 2x. Okay? Immediately, you can collect those like terms in your head. We need to start to make some of these really basic processes more efficient at this point. Okay? Because these are really fundamental skills to so many other things that you don't have time to be taking, wasting time expanding brackets. The more efficiently you can do it, the better. Okay, expanding brackets essentially becomes a skill that you need to be as efficient at as you are at adding, subtracting, simple arithmetic. Okay, the second one I want you to get more efficient at is the difference of two squares, and I want you to look to recognise this. So difference of two squares is when we're expanding it, is when we have two terms in each bracket, and it's the same two terms, the only difference being in one bracket there's a minus and in one bracket there's a plus. That's going to expand out very quickly and efficiently to just be the first term squared take away the second term squared. And that's because, again, if we use FOIL here, x minus a, x plus a, we do first terms, x squared, x times x is x squared. We'll get outside terms, so plus ax, inside terms, so minus ax, and last terms, negative a times a is minus a squared. And we see that ax plus ax minus ax cancel out, and we get x squared minus a squared. So again, we don't want to waste time with this line. We want to recognise, difference of two squares. Okay, here is your difference, subtraction of two squares, x squared minus a squared. So we want to look to recognise that. The third thing we want to be able to expand out without using a whole lot of lines of working is a perfect square. And again, this rule comes from using FOIL. If we have x plus a times x plus a, we get first terms x squared, outside terms plus ax, inside terms plus ax, and last terms is plus a squared. And so we get x squared plus, these are like terms, ax plus ax is 2 lots of ax plus a squared. And if it's a minus in the bracket, the only thing that will change when we expand out is we'll get minus ax and minus ax, so we'll be subtracting 2ax. Okay, so again, I want you to be able to recognise, right, x plus a all squared, it's immediately x squared plus 2ax plus a squared, and be able to write down the answer in one line rather than needing a couple of lines of algebra. I really want you to make that a focus as you work through this exercise, identifying and using the correct rules so that you're able to expand efficiently. Okay, let's work through the examples. So expand and simplify each of the following. So part A is just going to require our distributive law. The term outside the bracket must multiply each of the terms inside the bracket. So we get 2x on 5, I might write it out, 2x on 5 times 15x, just because there's a bit of thinking involved in that. And then we've got minus 2x on 5 times 4. Okay, so thinking about, multiplying fractions, this is 15 over 1, okay? So you shouldn't be doing 2 times 15 because the 15 will cancel down with the 5. And so actually we've just got 2 times 3, which is 6, x times x, which is x squared over 1, minus, and again, this is 4 over 1, so we're going to get 2x times 4 on the top, 8x over 5 on the bottom. Alright, so we've got 6x squared minus 8x to the 5. It would also be good if you were able to think a bit more efficiently in that process as well. So thinking about 2/5 of 15. What's 2/5 of 15? Well, 1/5 of 15 is 3, therefore 2/5 of 15 is 6. And straight away being able to see that that first term will be 6 times x squared. Okay? Right, expanding out the brackets here. So again, I don't want 4 terms. I want to be able to do this straight away. X times x is x squared. X times 5 is 5x, plus x times 6 is 6x, so 5x plus 6x is 11x, plus 6 times 5, which is 30. Okay, should be able to immediately write that down with no collecting like terms required. Okay, x plus 3 all squared. Again, we've got our rule for expanding a perfect square, which does come from FOIL, so if you can't remember it, yes, you can write it out and expand it out, but I really want you to try and practice being able to use these formulas so they're accessible to you when under stress in a test. X plus 3 all squared, so we're essentially treating, so we've got x plus a all squared modelled up there, so we're going to have x squared plus, because of the plus in the brackets, 2 times a, which is 3, and times x, okay, and then plus 3 squared. So again, I wouldn't write out that first line. I would do that in my head. I would simply go straight to x squared plus 6x plus 9. But just to show you where I'm getting these numbers from, I've written out that first line. If you can write it out straight from the brackets to the expansion, that's what we want to try and aim for. Okay, part D, we just need to be a little bit careful because of that negative, okay? Now we could expand the negative into the first bracket. So what I want to focus on first of all is you've got 3 things multiplying together here. So you've got 3, let's imagine 3 numbers, 3 times 5 times 2. Okay, we all agree that's the same as 3 times 2 times 5. It's the same as 2 times 5 times 3. The order doesn't matter. You're multiplying 3 things together. Here we are also multiplying 3 things together. So we do not multiply this negative 1 with both these brackets. That would be the same as us doing 3 times 5 and 3 times 2. We only do that if we have plus and a bracket. Okay, so we're not multiplying both things by negative 1 here. We're simply thinking about, okay, so you could either multiply the negative into the first bracket and have negative x plus 2, x minus 7, and then expand out the second multiplication. So that would be the same as saying, okay, I'm going to do 3 times 5, and then I'll take that and multiply it by 2. Okay, or you could instead choose to multiply those 2 things together, so expand out those brackets, and then after you've done that, multiply that by negative 1. That would be the same as working out 5 times 2, and then multiplying that by 3, okay, which we're allowed to do. So I would advocate leaving the negative till the end, okay, but it does mean you need to be a bit careful about, you are going to have negative whatever those brackets expand to, okay, so just be careful that you don't lose that negative, that everything needs to be in brackets. So expanding out those brackets, x times x is x squared. We're going to get minus 7x and minus 2x, that's minus 9x, and minus 2 times minus 7 is plus 14. Okay, so then thinking about multiplying everything by negative 1 now, we get negative x squared plus 9x and minus 14. Okay, the second set of brackets you might revert to using FOIL here because there's quite a lot going on. You might not, you might be able to do it in your head still, it's up to you. Let's see what we can do. So again, we're going to have first terms, 2x times 3x is 6x squared. Then we're going to have outside terms, 2x times negative 5, that's negative 10x. And then we're going to have inside terms, which is 3x times 1, so that's plus 3x. So again, I want to try and do that in my head. Minus 10x plus 3x is minus 7x. Okay? If you need to write it out, do it, but I want you to try and be able to do these quicker than that and do a little bit more in your head here. 1 times negative 5 is negative 5. Okay, f, again, the real thing we're going to need to be careful about here is the negative. Okay, you've got negative x times 3 and negative x times negative x. That's the one you'll miss. Okay, so expanding out both sets of brackets separately using just our single distributive law. X times 2x is 2x squared. X times negative 5 is minus 5x. Then, as I said before, we've got negative x times 3, which is negative 3x, and negative x times negative x, which is plus x squared. Alright, we've got some like terms there. 2x squared plus x squared is 3x squared, and minus 5x minus 3x is 8x. Okay, part G, again, like part D, we could choose to expand the 2 into this bracket and then multiply all of that by this bracket, okay? But I would prefer personally to expand out these brackets while they're in this simpler form and then multiply everything by 2, okay? Remembering you don't need to multiply both brackets by 2. That's the same as saying if you've got 2 times 3 times 5 that you're doing 2 times 3 and 2 times 5, which you're not. You're just going to do 3 times 5, which is 15, and multiply that by 2. You're not doing 6 times 10, okay? Okay, so leave the 2. You're going to have 2 times everything, expand out the brackets. X times x is x squared, plus 4x minus 3x is plus x, and minus 3 times 4 is, minus 12. Then you're going to have 2 times all of that, so 2x squared plus 2x minus 24. Okay, and lastly here again we've got, I'm going to add one more example on actually because I've left something out. Here we've got a perfect square again, so remembering that our perfect squares, a minus b all squared is a squared minus 2ab plus b squared. So same thing here, this is a, this is b, okay? So we're going to have a squared, 3x all squared, minus, because of the minus in the brackets, 2 times a, which is 3x, and times b, which is 4, and then plus b squared, so plus 4 squared, so plus 16. I'll write out the 4 squared. Again, I wouldn't write out this line. I would do that simplifying as I go and just get straight to my final answer, which is 9x all squared, take away 2 times 3x times 4, so that is 24x, and then plus 4 squared, which is 16. I'm just going to add one example on here, A, B, C, D, F, G, H, I. And can we just have a think about, let's say if we've got 3x plus 2 and 3x minus 2. Again, we could use FOIL, but we want to recognise here that we're going to get a difference of 2 squares because we've got this same 2 terms in both brackets with a plus in one and a minus in the other. And when we expand that out, we get the first term squared minus the second term squared. So that is 3x all squared minus 2 all squared. So 9x squared, take away 4. Okay, some practice to do there. It looks like quite a long list of questions, but once again, you should be able to straight away write down the answer for each of these questions.